Good day and welcome to Medley School's tutorials. In our chemistry today, we are looking at Ionic Theory, objectives. At the end of the lesson, the student should be able to explain what Ionic Theory is, and also the student should be able to explain what an electrolyte is, and also differentiate between electrolyte and non-electrolyte. The student should be able to define electrodes and also give two examples of what? Of electrodes. Today, we are looking at Ionic Theory. And we said that the Ionic Theory was first presented by a scientist called Ionic in 1887, where he used this theory to do what? To explain electrolysis. The theory proposed that when an electrolyte is melted or dissolved in water, some, if not all, of the molecules of the substance dissociates. In what? Dissociate freely, that is, moving charged particles called ions. When we talk about dissociation, we are talking about separation of what? Separation of ions. So the process of this dissociation into ion is known as what? Is known as ionization. Like in acid, when a substance is dissolved in water, what happens? There is a dissociation of what? Dissociation of ion. That's why we say that acid is a substance which, when dissolved in water to produce what? Hydrogen ion. Is when it is dissolved in water that we have what? Separation of what? Ions. And in that context, you say that what? Ionization has what? Taking place. So now, where there is what? Dissolution of what? Dissolution of substance in water, there will be what? There will be separation of ion. And when that happens, you say that what? Ionization has what? Taking place. So in this theory, this Arrhenius presented this what? Presented this theory as the best approach to do what? To explain what? Electrolysis. Also, here now, after the dissociation of the ion, which we call ionization, we see that the metallic ions, ammonium ions, and hydrogen ions are what? Are the positively what? Charged what? Ions. While the non-metallic ions, like the hydroxide ions, are what? Are the what? Negatively what? Charged ions. Now, when we take this theory in a nutshell, we see that this Arrhenius is telling us how electrolysis works. And here now, he said that when a substance is melted or dissolved in what? In aqueous solution, there will be what? There will be dissociation of ion. That is what we call ionization. And when that happens, there will be what? Separation of ion, where you have what? The positively charged ions and what? And the negatively what? Charged ions. Also, here we have what we call an electrolyte. This electrolyte is a compound which conducts electricity and is decomposed in the process to behave as what we call an electrolyte. The compound must be in liquid from either as the molten compound or and what? Aqueous solution of what? Of the compound. So this substance we are talking about now, in this electrolyte, is a compound that does what? That conducts what? Conducts electricity in a molten form, or we say in aqueous what? In aqueous solution. So when such compound conducts electricity, you do what? You term that compound as what? As electrolyte. So it will be in what? In molten what? Solution, or in aqueous solution, and does what? And conducts what? And conducts what? Electrolyte. And once you see such compound, you say that it has behaved as what? As an electrolyte. Also, the non-electrolyte, they are the compounds that what? Do not conduct electricity. In what? In such manner. That is, in the manner of what? Electrolyte. They are covalent and what? Are mainly organic what? Compound. Example, when we take this urea. Urea, we know what urea is. Urea is contained in urine. It's a compound. When you use urea now, maybe now you get a a tin of milk, that is the used one, you put what? You put a urea, you get what? Two rods, one serving as what? Cathode, and the other one serving as anode. Then you do what? You connect wires. The wire you are connecting now, you put what? Source of electricity. You connect one to what? 1.5 volts of what? Of cell. You connect one to the positive side and connect the other one to the what? To the negative side. So when you do that, you see that when you use urea, ethanol, benzene, ether, trichloromethane, cane sugar, and tetrachloromethane, you see that what? It will not what? Conduct what? Conduct electricity. But when you use like H2SO4, which is what? Which serves as an electrolyte, you will see that when you connect the source of electricity, you will see that what? There will be what? Bubbles in the what? In the liquid. In that case, you say that that particular compound has behaved as what? As electrolyte. So in that case, it will what? It will conduct what? Electricity. Also, we have strong electrolytes. The strong electrolytes, we have strong electrolytes like salts, conduct large current, since they are composed entirely of what? Free mobile ions. So in this case now, you have that in this strong electrolyte, they have what? They have large what? Free mobile ions that do what? That moves freely. Ions that moves freely. In that case, they can do what? They can what? Conduct what? Much electricity or large current. They can possess what? Large current because of what? Free mobile ions. Because the ions are what? The ions are free and they are what? They are many. But when you get to weak electrolytes, because in strong electrolyte they ionize completely in what? In a solution. But in weak electrolyte they ionize what? They ionize partially in what? In solution. Because they ionize partially in solution, there will be no what? There will be what? Just a little or no dissociation of what? Ion. That is what we call what? Ionization. The ionization we see in weak electrolytes are very what? Are very small. So because of that, they cannot be able to do what? To conduct what? To conduct electricity. So when we look at this weak electrolytes, we say that they ionize only slightly and so do not conduct what? Electricity greatly. Example, we have the what? The ethanoic acid. Because in ethanoic acid, you see that when there is a dissociation in ethanoic acid, it has what? 4 hydrogen atoms. It's only 1 hydrogen ion. If you split it, if dissociation occurs, you will see that you will have what? Normally you have what? 4 hydrogen atoms, but ionically, when dissociation occurs, you will see that it is only what? 1 hydrogen what? Ion that will do what? That will dissociate. So in that case, you see that it has what? Few ions. Also, the electrodes. These are conductors in the form of what? Wires, rods, or plates through which an electric current enters or leaves the what? Or leaves the what? The electrolyte. So here now, this electrode now, in electrode now, we have what we call cathode and what? An anode. So it is what? It is an avenue, or we call it is a conductor through which what? Through which current enters or leaves the what? Leaves the what? The electrolyte. So with this now, you can be able to do what? To differentiate between what? Electrolytes and what? And non-electrolytes. But have it in mind that the main objective of this topic is what? Which these scientists are talking about is to do what? To present to you that what? That there is a compound that conducts what? Conducts electricity in what? In molten form or what? In aqueous form. And this happens because when it dissolves or melted, ions in it what? Dissociate. That is, ionizes to form what? To produce what? More mobile and more free ions that we do what? That we conduct what? The electricity. And also, you should have in mind that in this electrolyte, we have strong and what? Weak electrolyte. The strong one is the one that has more free mobile ions, while the weak ones are the ones that can do what? Produce few or no ions. And in that case, they cannot be able to do what? To to conduct electricity. So I believe with this now, you can be able to explain whenever you are asked to do what? To talk about what? Electrolytes, non-electrolytes, electrodes, strong electrolytes, and what? And weak electrolytes. Thank you for watching. See you in the next video.